Hey everyone, and welcome to This Explainer. So if you're gearing up for a Java developer role, whether that's an entry-level software engineer gig or you're aiming all the way up to principal engineer, you've probably felt that familiar sense of dread looking at study materials that just seem absolutely endless. I mean, our source material today is literally titled 1000 Java Interview Questions. Facing a list of 1,000 questions, yeah, that can make anyone break into a cold sweat. But here is the secret to passing your technical screen. You do not need rote memorization. What you actually need is to master the core architectural buckets, because once you understand the fundamental why behind the code, well, the what and the how just fall right into place.
Now, I want to talk directly to you here. How are you actually planning to tackle this massive list? Are you just going to read them one by one like a dictionary? No way. We need a way better strategy. Assure yourself right now, building a strong mental model is the answer. If you can visually group these core concepts in your mind, you're going to be able to navigate pretty much any curveball an interviewer throws at you. To help you out, we're going to visually distill all that chaos into 5 highly manageable sections. We'll cover decoding the Java environment, the pillars of OOP, classes, interfaces, and modifiers, overloading versus overwriting, and finally, memory management and garbage collection. Let's dive right in.
All right, Section 1, Decoding the Java Environment, the true bedrock of Java.
You know, interviewers absolutely love to ask why Java gets called a write once, run anywhere language. Well, the secret sauce here is the Java Virtual Machine, or JVM for short. The JVM is basically an abstract machine that executes Java bytecode. See, when you compile your Java code, it turns into this bytecode. Then, a JVM, which is actually written specifically for different hardware and software platforms, takes that bytecode and runs it. The JVM is literally the engine that gives Java its famous platform independence. It's a real game changer. Now, when the JVM is actually running, it has to allocate memory. I like to think of this as setting up a perfectly organized physical workspace for your code. It chops memory up into very specific areas. You've got the class loader to load files, the class or method area for per-class structures, the heap where objects are allocated at runtime, the stack for local variables and method invocation, the program counter register to track instruction addresses, and finally, the native method stack for native application methods. If you can just visualize this workspace in your head, you'll easily be able to answer questions about where data lives while a program is executing.
Moving on to Section 2, the pillars of object-oriented programming. Think of this as your architectural blueprint.
Okay, so there are 4 main principles of OOP: abstraction, encapsulation, inheritance, and polymorphism. Look, every developer absolutely has to know these inside and out to pass a technical screen. Abstraction is all about hiding implementation details and showing only the essential features. Encapsulation, which you'll often hear called information hiding, protects variables using getters and setters. Inheritance is what lets objects share common behavior through a parent class. And polymorphism? That allows the JVM to decide at runtime which exact method to call based on the object type.
But the real test is knowing how these pillars apply. Or, more importantly, when they don't apply. Interviewers are definitely going to try to trip you up with tricky hypothetical prompts to test your boundaries. Like this one: can we inherit a constructor?
The answer? A hard no. Java does not support the inheritance of constructors. Knowing this specific rule right off the bat is going to save you from falling into a classic interview trap. Constructors are totally unique. Their job is to initialize an object, and they share the exact name of the class. So, they aren't standard methods that just get passed down the inheritance chain to a child class.
All right, let's hit Section 3, classes, interfaces, and modifiers. This is all about structuring the code. Here's a question you're almost guaranteed to hear. What's the difference between an abstract class and an interface? Seriously, this is arguably one of the most common comparison questions in all of Java interviewing. It perfectly tests if you really know how to lay out the blueprints for other developers to use.
So, let's put them side by side. An abstract class, it can actually have implemented methods, non-abstract methods with a real body, and it can have instance variables. But an interface, historically speaking, it strictly has abstract methods and absolutely 0 instance variables. It only holds constants. Oh, and don't forget, a class can implement multiple interfaces, but it can only ever extend one abstract class. That's a crucial distinction.
Okay, here's another classic trap question that always seems to catch beginners off guard. Is it possible to execute a program without a main method? Back in the day, in earlier versions of Java, crafty developers used a little workaround with static blocks to pull this off. But what about today?
Today, the definitive answer is no. From Java 7 onwards, a main method is absolutely mandatory to execute a program.
The creators of Java actually went in and closed that little loophole. Delivering this answer, and specifically name-dropping that historical change from Java 7 onwards, is a great way to show your interviewer that your knowledge is both deep and totally up to date.
On to Section 4, overloading versus overriding. Let's get into the tricky nuances.
So what actually is the difference between method overloading and method overriding? I mean, they sound almost identical, right? But they represent two totally different concepts in Java polymorphism. You've got to have a crisp, structured way to tell them apart when you're put on the spot. Here's the breakdown. Overloading is static polymorphism. It happens at compile time, strictly within the same class where methods share a name but have totally different parameters. Overriding, on the flip side, is dynamic polymorphism. That gets resolved at runtime. It happens between two classes in a parent-child hierarchy, and here the methods must have the exact same parameters. Seriously, memorize this side-by-side contrast. It's super important.
Because once you have that model locked in your head, you can handle those hyper-specific curveballs, like, are we allowed to override a static method in Java? Interviewers love using this one just to see if you actually understand why overriding works, rather than just regurgitating a textbook definition.
And the direct answer is no. Java simply doesn't allow overriding a static method. Why? Well, because overriding requires an instance of a class to do that dynamic runtime lookup we just talked about. A static method is associated with the class itself, not any specific instance object. So the very concept of overriding just does not apply here. If you create a static method with the same name in a subclass, you're really just creating a brand new method, not overriding the old one. Finally, we've reached Section 5, Memory Management and Garbage Collection, the behind-the-scenes magic.
So garbage collection in Java is basically an automated daemon process running inside the JVM. Its whole job is to monitor memory usage and snatch back memory from unused, unreachable objects. Because Java doesn't use manual memory pointers like C++ does, you don't have to sit there manually deallocating memory. Instead, you can think of the garbage collector as this invisible background cleaning crew that tirelessly sweeps up your mess whenever your JVM starts running low on memory.
Let's break this complex backend lifecycle down into 3 really simple, easily memorized steps. Step 1. An object becomes unreachable by any live thread. Step 2. The JVM calls the finalize method, which actually gives the object one last chance to perform any custom cleanup before it gets destroyed. And Step 3. The garbage collector daemon officially reclaims the memory. Showing you understand these exact steps proves to the interviewer that you really comprehend the underlying system health of Java applications.
And just like that, you've completely bypassed the need to blindly memorize 1,000 separate questions. We've covered the memory layout, the OOP pillars, structural modifiers, polymorphism, and the whole garbage collection lifecycle. You actually understand the core architecture now. So the next time an interviewer asks you some hyper-specific question, just fall back on this visual blueprint. The only thing left to ask is, are you ready to ace the interview? Take this framework, prove you understand the why behind the code, and go get that offer.